Hello everyone and welcome to today's programming video. In today's video, we will solve the Leetcode problem called container with most water. In this problem, we have been given an integer array height of length n, and each value or each number in that array represents the height of a line, the vertical height or height of a line. So what we need to calculate here is the maximum amount of water a container can store, and two lines together form a container. So we need to find two such lines where the amount of water we can store is maximum, and we need to return the maximum amount of water that we can store there. And we have been also given that we can't slant the container. So let's first understand how we can calculate the amount of water between two lines in general. In this example, we have been given the array height, which contains the heights of lines here, and between any two lines we can store certain amount of water, and we need to find what is the maximum amount of water we can store given these line heights. So let's look at the two red lines which we have here at index 1 and index 8. Because we're filling water here, we can only fill it up to the brim, and that is the smaller of the two heights. So the breadth, if you want to calculate the area, we need length and breadth. So the length here would be the distance between the two red lines, and that is 8 minus 1, 7, and the breadth would be 7 here because that is the smaller of the two line heights, and therefore 7 times 7 equals 49, and that would be the amount of water we can store between line index 1 and line at index 8. Now let's think of an approach we can use to solve this problem. So let's take an example of lines and try and find what is the maximum amount we can store between them. Let's take a subset of lines and see how we can find the maximum amount of water we can store in between those lines. So let's take the lines between say 3 and 6 here. So ignore the lines outside of this green box for a moment. So let's say we want to find the maximum amount of water between these lines, between 3 and 6. So it could be 3 and 6 or 3 and 4, 4 and 6. We don't know yet. So let's start off with 3 and 6. So between 3 and 6, how much water can we store? So the distance between 3 and 6 is the length is 3 times how much is the maximum height of water we can have, and that's actually just here, that is 2. So 3 times 2 is 6, so that's the amount of water we can store here. Now let's see between 3 and 5. So let's say 3 and 5, how much water can we store? So the distance, the length is 2 because 5 minus 3 is 2, and the minimum height is here is 2 again, and that is 2 times 4, 2 times 2 is 4. Okay, so we checked 3 and 5. Now let's check 3 and 4. So between 3 and 4, how much water can we store? That is 1 times the smallest of the two, and that is the height 2, and that happens to be 2. So we can observe here that between 3 and 6, the lines at indices 3 and 6, the amount of water we can store between 3 and 6 is more than what we can store between 3 and 4 and 3 and 5, and that is because 3 happens to be the smaller of the two. So the line height at 3 is 2 and the line height at 6 is 8. So no matter what heights the lines are in between, it's always going to end up being like the bottleneck here, 3. So if let's say the line at index 4 was say 1, then it would be even less. So there's no point in checking. So because the height of the line at 3 is less than the height of the line at 6, okay, this is important. The height of the line at 3 is less than the height of line at 6. We don't need to bother checking the amount of water between 3 and 5 and 3 and 4, because it's going to be less than the amount of water between 3 and 6. Let me give you another example to clarify this point. Now ignore the lines outside of this purple color. Now let's calculate the amount of water we can store between 1 and 4. So 1 and 4, how much can we store? So we can store length times breadth, so that's 4 minus 1, 3. That's the length. And what is the breadth of this rectangle? Which it will be the smaller of the two, because that is the max amount we can fill up to. So that will be 5, and that's multiplied, we get 15. Now let's look at 4 and 2. So remember, the point I'm trying to drive home is that given two lines, okay, the shorter line becomes like the kind of bottleneck between the lines we have. So for example, now if you check 2 and 4, so meant bottleneck, so actually it's kind of threshold. So between 2 and 4 we have 2 times the max is actually 5 again, so 10. And between 3 and 4 it's even less, it's just this much water here, so it will be 1. So 4 minus 3 is 1 times 2, so that's 2. So we can see here that given any two lines, let's say this red lines at index 1 and 8, and we can see that the smaller of the two lines is at index 8, and that is the max amount of water we can fill. We do not need to check the amounts of water between 2 and 8, 3 and 8, 4 and 8, 5 and 8, 6 and 8, 7 and 8, because it is going to be less than 1 and 8, because 8 is the threshold between 1 and 8. It's the smaller of the two. So let's say we have 2 pointers, I and j. Okay, now we can calculate the area between these two. Before we iterate through this array, we can store max as 0, and that will be our result. So we calculate the area between I and j. Once we've calculated the area, we can check if it's greater than max. If it's greater than max, then we update max only if it's greater than max. Once we've done that, we can check, okay, which one is got a smaller height. In this case, I, the line at index I, has got a smaller height. That means that we don't need to check the areas between 0 and 7, 0 and 6, 0 and 5, 0 and 4, 0 and 3, 0 and 2, 0 and 1. There's no need to check that. So all we need to do here is increment I by 1 position. And once we've done that, we now recalculate the area. And then if it's greater than max area, we update it. At this point, we can see that the height of the line at I is 8 and the height at index 8 is 7. So we have already calculated the area between these two. There is no point in calculating the area between 2 and 8, 3 and 8, 4 and 8, and so on and so forth. So we simply move j 1 position to the left, and that way we are kind of skipping over the in-between lines and optimizing the calculation. So we will recalculate the area, and if it's greater than max, we will update max. So we'll continue this loop till I is less than j, and when the loop finishes, we will have our result in the max variable. Let's look at the code and implement this logic. Initialize my 2 pointers I and j. So I points to the first line and j points to the last line. Now I will iterate through this array, and in every iteration we will update either I or j, and in each iteration we will check which is the maximum area. So let's define a variable for the maximum area. So let's now calculate the area between the lines at index I and j. And as you've seen earlier, it will be length into breadth. The length is the distance between I and j. And the breadth is the smaller of the two heights. Once we've calculated the area, let's see if it is larger than the maximum area that we have calculated so far. And if it's greater than the max area, we'll update max area, or the max, to be the new area that we just calculated. Now we saw that there's no point in calculating the area between the smaller of the height and all the in-between heights. So for example, if we wanted to check 0 and 8, because the line at index 0 is smaller than the line at index 8, there is no need to calculate the area between 01, 02, 03 up till 07. It is enough to calculate just the area between 0 and 8, because all the other areas between 0 and 8 will be less than the area between 0 and 8. So I'm checking that if the height of the line at index I is less than the height of the line at index j, then I don't need to calculate the in-between areas. I increment I by 1. Otherwise, I decrement j by 1. And that way we will finish this loop eventually, and then finally we will return the maximum area that we have calculated, or the maximum amount of water that a container can store. Okay, let's give it a run. Let's run some more test cases here that we've got. Okay, that's great. Thank you very much for watching, and hope you like the video and find it useful. Please do remember to like and subscribe. Thank you. Bye.